we now need to apply equations of motion, and particularly to road safety. Really what we're looking at is how long does it take someone to stop? And we have to consider something called reaction time. Even though we know we need to stop, so if we're driving in a car and the driver sees an obstruction in front, it takes them a little bit of time to realize they need to press the brakes, and we need to consider what that time is. So we get a thing called braking distance. Now, braking distance in a car is always worked out by the manufacturers, and it's the shortest distance that it takes for the brakes to stop a motor vehicle. That makes sense? Okay. Thinking distance changes from person to person. Now, this is the distance that a car travels at constant speed before you apply the brakes. So I'm traveling along on the road at a certain velocity. I see something in front of me. I know I've got to push on brakes, but it might take me a second or half a second or 3 seconds, heaven forbid, for me to before I actually push the brakes. That's my thinking distance. My stopping distance, therefore, is the braking distance plus my thinking distance. That's how long it actually takes us to stop. So when you hear things like you must always be 3 seconds behind a car or whatever, you'll learn this when you learn to drive. And when it's raining, you need to be even further away. It's not that distance that's only needed for your car to stop in terms of getting slower. But it's how long it takes you to react. So thinking this is the thinking distance is the thing that makes the biggest difference. Because braking distance for every car will be the same if its brakes are being pressed at the same hardness, okay, with the same force. So that's quite important. Let's do an example. Oopsie. Come on. It doesn't want to move on. There we go. Why not? There we go. Okay. Let's change our pen color again. Let's go for, I don't know, green. Sounds like fun. So, a car is traveling at a constant velocity, so that's my initial velocity, on a long straight road. The driver suddenly sees a man standing in the middle of the road. Well, that's a bad place to be standing in the first place. 140 meters away from the car. It takes him, so this is the situation. This is my initial velocity. That should have a -1 there. So this is initial velocity. It takes him 2 seconds before he slams on brake. So even though I've got 140 meters to stop in, all right, for 2 seconds, he doesn't start stopping. So for 2 seconds, his acceleration is 0. They want to know how far does he travel during those 2 seconds. Well, final velocity is 20. Initial velocity is 20. A is 0. Delta T is 2. And we need delta X. Well, we can pretty much use any delta X equation. Use the simplest. You absolutely, if you wanted to, could try use this one. But because V and F are the same value, you're going to end up dividing by 0 anyway. And A is 0, so it's going to be useless. We put in what we know. Put in what do we know. Oh, sorry, guys. Put in what we know. That gives us 40 meters. So even though he's got 140 meters to go, 40 meters is traveled before he even thinks about slamming on brakes. Now they want the acceleration needed for the car to stop. Now remember, I've already traveled 40. My total distance from here to here was 140. That means he has to go 100 meters. All right? I don't actually know how long that takes. The time I had was for this first part. So I don't know how long it takes. Vf squared equals Vi squared plus 2r delta x. I can't use the one with delta t. So 0, 20 plus 2a. He's going to have to go at 2 meters per second squared in the opposite direction. 2 meters per second squared backwards. Okay? That's really, 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 really important. Okay? So, now calculate the time taken to come to a stop from the moment the driver saw the car. So, remember, the first 40 meters took 2 seconds. We now know acceleration for this one. We know the acceleration. We worked it out as -2. We know initial velocity, it was 40, I think. Final velocity is 0. And we know delta x, and we know time. So we can VF, we can pretty much use any equation. So use the easy one. VF equals VI plus A delta t. 0 is 20 plus -2 times delta t. -20 equals -2 delta t. T is 10 seconds. So my total time is the 2 seconds it took to do the 40 meters and 10 seconds for the last. So it's 12 seconds. Just need to think this through. You need to do some extra calculations. But hopefully you can now do equations of motion.